I want to point out that the sun shines down its power to all the world and makes the wind blow strong as it will. I want to hope gentle rains can fall upon the land, so lovely earth can stay lovely still. What I want to do now is welcome everybody to a special of Energy Week, and we are going to be talking about nuclear waste with Alex Fay and Steve Reucroft. Wave to the people, Steve. We all waved at the same time.
Everybody waves, so you still don't know.
You don't know who it is. Oh, this is so much fun. Anyway, we're going to talk about nuclear waste, which is a fun project. Let's talk about nuclear waste and what we're going to do with it. Alex.
All right. Well, so I just get right into the kind of stuff we've been researching?
Well, you and Steve have been working through the summer, and you've been finding that there are a bunch of things that we can talk about.
Maybe I should start by just explaining how Alex got involved. That might be more, and then he can tell us what we're doing. Tell everybody what we're doing.
Yes.
Because I've been kind of harping on this nuclear waste issue for a few years, as George knows, right?
Yes.
And with little to no success.
Right.
And I have slowly realized that most people just simply don't care about the problem.
I don't know that they don't care, but I think a lot of people don't want to care because they want to push something that they can't deal with out of their
maybe,
lives.
but I've talked to a lot of people, and I've slowly got the message. And the perfect example is a guy I was talking to a couple of weeks ago, and he happens to be in his early 60s. And he was asking me what I've been doing, and I was telling him all about this terrible problem of this nuclear waste. There's hundreds of thousands, probably millions of tons of it. It's radioactive for millions of years, and it's lethally toxic stuff. And it's hanging around in many different sites all around the planet. And in almost every site, probably every site, is near water. And once any of it gets into the water, we're all doomed. All life form on this planet is doomed. So I was saying this to this guy, and he said, you know, Steve, to be honest, I don't care, because it's not going to be a problem for me, and it's not going to be a problem for my generation. And a light bulb went off that we've just got to get young people into this problem. Just introduce young people to this problem, because it really is their problem, because the old guys can't do anything about it. I mean, the politicians clearly can't do anything about it. And I gave Alex a report I was reading about a week or so ago about the famous 34 tons of plutonium. Do you know about this story? Back in 2011, the US and the Russians signed an agreement that each of them will get rid of 34 tons of nuclear weapons grade plutonium. They claim they don't need it, and of course they don't need it. It's surplus, 34 tons. They've got enough nuclear weapons, so they agreed to get rid of it. Even though, by the way, it cost many billions of dollars to create this awful stuff, they've agreed to get rid of it, to destroy it, to get rid of it somehow. Now, the Russians immediately came up with a scheme, and unfortunately the US government, the politicians, are still arguing about what to do with it. And in the meantime, the estimated cost of getting rid of the 34 tons, and we know of at least 300, 400,000 tons of this stuff. Maybe millions, it's probably millions, but 34 tons is a negligible little piece of the pie, and they can't agree on how to do it. And the agreement expires next year, so it's looking like nothing's going to happen. And the report I was reading was pointing out the cost of the various options, and the cheapest would be $9 billion to get rid of 34 tons, the cheapest. And that involves mixing it with stuff that is not radioactive. I mean, it doesn't say what, but it's probably sand or something. I mean, it could be anything. And burying it. That's the cheapest option. It will cost, estimated to cost $9 billion.
Now, this would be probably vitrifying it.
No, I don't think so. I think they have a different name. I've got the report here somewhere. It's got a name that I can't remember. Can you remember what they call it when they add it to something else? They call it Oh, down blending. They call
Well,
it
yeah.
down
But
blending.
I cannot imagine a way of getting rid of plutonium in this manner that wouldn't be vitrifying it. You've got to protect it from what it
Yeah,
might
you would
hit
think
it.
so. Anyway, they're going to do something. That's the cheapest. The most expensive would be, I don't know what, I can't remember, destroying it with neutrons, I think. The estimate would cost 50 billion, which I think is really wrong. But anyway, whatever, they're not doing it. I mean, these are old guys. They're guys like me and George and my friend who said he doesn't care. So I realized, look, we've just got to get young guys into this. So about the same time, I met Alex, and Alex didn't know too much about the problem. So I said, look, why don't you, on your own, just as a little independent project, dig into the problem and find out everything you can about the problem. And I didn't tell him, but I was pretty sure this would motivate him to do something about it. And by golly, it has. It really has motivated him. And now, hand over to you. What are we going to do?
Well, what we're going to do is, so we're going to launch a Kickstarter. And hopefully, if we reach our goal of $100,000, we can hire some experts, nuclear engineers, nuclear physicists, and we can kind of put together a little group. And we're going to throw together a document that's going to basically put together all the research we've done this past summer. And with the help of these nuclear engineers and physicists, we can fine-tune it, make sure everything's right. And it's essentially going to explain our view on what the best solution is. And there might not be a best solution because different conditions everywhere.
Mm-hmm.
Different sites might be more suited to a certain solution. But basically what we think is the best, maybe most cost-effective solution to this problem. And we're going to sell it, get it out there, and hopefully we can start, motivating people to deal with this problem because...
Young people.
Yeah, young people, because people seem content to think that this is a problem for the next generation. But that's not true. A 2011 estimate put down that there were probably about hundreds of thousands of tons of this very, very radioactive stuff. And that was 2011, and it's likely to have gone up by a lot since then. And this is all stuff that is just kind of sitting there. And what I'm worried about is, at what point do we just have too much that we can't deal with it before it's too late?
All right. Now I want to stop you on two issues here. First of all, some of the people watching this show probably don't know what Kickstarter is. So we should probably tell them how that works. And there are many different ways of doing this. Kickstarter is just one of them. But this is a service that is provided by organizations, Kickstarter being one, which makes it possible for people to fund projects.
Yeah, it's called crowdsourcing.
Crowdsourcing.
Right.
Now, crowdsourcing has been very successful in a number of different things. One of the examples that I come up with a lot is a wind turbine that a town in Holland, I believe, wanted to put in, and they put this thing up for crowdsourcing, and the wind turbine, which cost $1.5 million, was 100% funded in 20 hours.
Yeah.
And it did not have to go, they didn't have to go through the same kind of organizational channels that they would if they wanted to go to a bank or form a whatever, a company. I believe it was a co-op, so it was a fairly simple system to do in the place where they were doing it. The other thing, though, is this, and that is, I would like to just mention one thing about the toxicity, and that is, we're talking about plutonium. Are we talking about all nuclear waste?
All high level.
All
high
high level
level.
nuclear waste, okay. When we're talking about weapons grade plutonium, a friend of mine many years ago was a toxicologist, and about a very fine toxicologist. He was the head of product safety for Colgate-Palmolive, and he told me that he had on one occasion done a calculation on how toxic plutonium is. And he said that at that time, when the population of the world was perhaps 3.5 billion or 4 billion people, he figured that 2 kilograms, if it were evenly distributed among that population, would be sufficient to kill 100% of it.
Yeah.
This is very, very dangerous
But you
stuff.
know, very important thing about plutonium, I mean, if I gave you a kilogram, you hold it in your hand, it's really not dangerous. It's an alpha emitter, and alphas are absorbed by the skin. So
Yes.
it won't get into your system, won't do any
Yes.
damage.
Yes.
But if you ingest just one tiny little fragment of this stuff, it stays inside you. Then the alphas do damage internally, and it's deadly poisonous.
And on top of that, when it decays, it produces different isotopes, which have additional problems. So but the decay inside
I think it
you.
decays to uranium, doesn't it? It emits an alpha and becomes uranium, I think.
That sounds like it's probably right. But if it gets into your lungs,
Yeah,
there is nothing. There's no skin between it and the
that's right.
and the cells.
There's nothing can save you.
And so the result of that is that those cells that are in the vicinity of where it exists
Yeah.
are very likely to become
Yeah.
cancerous.
It's often described as the most toxic material known.
And we've got many tons of this.
Oh,
And in addition to that, we've got many tons of other stuff
Which
that is
are-
nuclear waste that includes a certain amount of it.
and they're all dangerous in slightly different ways. But the heavy metal ones, like plutonium, people have probably read a lot about polonium recently, because there are stories about the old KGB murdering its enemies by getting them to ingest a tiny bit of polonium, which is another heavy metal that's radioactive and toxic. And here's the point, though, that, I mean, as long as the plutonium stays there in a concrete box in a grassy field, it's not really that dangerous. But, you know, we live on a dynamic planet, and you can't guarantee that things are going to stay where they are for longer than a few years. And once it gets into the water, as George said, 2 kilograms would kill every living thing on the planet.
Yeah, if it were distributed
If it's
to the
distributed
people.
uniformly.
But of course, when you're talking about the tons that we've
Well,
got,
34 tons is, can you work that out? It's about 34,000 kilograms, isn't it? 34,000 kilograms. So that'll kill everybody 17,000 times over
or if you distribute
if
it.
you distribute it unevenly. Anyway, it's nasty stuff. It really is nasty stuff.
And so, by the way, are the other products of
they're all
nuclear
nasty
waste.
things, all of them, and you know, it's just hanging around
Strontium
waiting.
90.
There's going to be a disaster one day. It's
Well,
bound
we've
to happen.
actually had a
The
couple of
probability is
disasters.
100% of
Yes.
a disaster, not 212%.
We have
100%.
had a disaster at Chernobyl, which had a reactor explode. We had a disaster at Fukushima,
Right.
which saw, I believe, one of those reactors almost certainly exploded at Fukushima because
Probably, yeah.
there were fragments found over a mile
You know,
away.
there's a significant increase in incidence of thyroid cancer in young people.
Yes.
in
They
in
have
that
had
region right now.
104 diagnosed cases.
Yeah, I know.
That was announced just a couple of days ago.
But can I go back to Kickstarter and just
Yes,
add something to
absolutely.
what Alex was saying?
Yeah.
I mean, there are two important things here. Alex has connection with a lot of like-minded young individuals, and he's going to talk to them and convince them that, you know, we have to do something. We just can't rely on the current generation to do anything. So we've just got to get the next generation involved already. And that's what Alex is doing. But secondly, he said that our Kickstarter campaign, we're shooting for $100,000, which of course is real peanuts. I mean, the US government estimates billions of dollars just to get rid of 34 tons. And I think you can do it less expensively than that report says, but 100,000 is nothing. And so why would we ask for such a small amount? And I think the point really is there that we're really looking for a symbolic funding seed, something just to prove that there are people out there who are willing to contribute $20, $50, $10, whatever, you know, a small amount. That's what crowdsourcing means. A lot of people each contribute a small amount of money. And if we can get a grassroots interest in providing some funding, that's such an important step forward. Everything I've tried up to now indicates nobody cares. And this would be a hugely symbolic step showing that really there are a lot of people out there who do care. And we have to do something about it. Then we will put together a report. I mean, that sounds stupid, but we're going to put together a report as part of the Kickstarter project. And we'll bring some nuclear engineers in as well and try and get a lot of publicity for it. But then we're going to have to get more money from somewhere to really move and actually do something somewhere. And that's going to be the second step. The first step is getting a bit of money just to prove that people care and launching the project to do something about it.
Mm-hmm.
And Alex is our leader. He's the leader of the project. I'm helping him as much as I can, but I'm the old generation, you know. I don't care about nuclear waste.
Yeah, oh, yes, you do.
Yeah, I do.
I care about nuclear waste, and a lot of people in our generation do care about it.
Probably they do, yeah.
And I
maybe
don't know
they're
how
paralyzed, not knowing what to do about it. I mean,
well, I think part of the problem is that a lot of people who are involved in it and have been involved in it for many, many years are unaware of the fact that you can deal with this.
You can.
And the technology for turning plutonium, which we've described as being incredibly deadly, into something other than plutonium, has existed for many years.
Yeah, that's right. That's right.
So, Alex, assuming you get your Kickstarter money, you've said you'd put together a team, but what are the technologies that you think might be examples that people can look at and say, I could support that?
Well, I've been looking online and I've been looking at different things. There was like an IFR prototype back in not too long ago. The U.S. was working with it, and it could basically take nuclear waste and mess with it, and turn it into energy. And the waste it produced, similar to the thorium reactor that Steve's been telling me about, it produces waste that is less radioactive, and it's like radioactive for, I'm not sure if it's less radioactive, but it's radioactive for a much shorter amount of time.
That makes it more radioactive.
Right, yeah.
But that's okay, because it's a shorter time, and that's what you want.
Yeah, so we only need to hold on to it, for the short amount of time until it's decayed, and then it's fine.
Yeah, and what we're talking about here, for example, now you're going to have to explain something in a minute, but what we're talking about here is, for example, the energy amplifier, the accelerator-driven system, can take nuclear waste and turn it into something that will be
the energy amplifier was as an invention of a European guy called Carlo Rubbia, and he designed it and he got it patented so that you can operate in several different modes. You can either operate it in a mode that produces energy, or you can operate in a mode that just eliminates high-level radioactive waste. Mm-hmm. And it's a type of nuclear reactor. It's a nuclear reactor that uses thorium instead of uranium as the fuel, and you have to have an external particle accelerator to generate neutrons to drive the whole process. But that's just one example. There's a Los Alamos patent that actually was taken out a little bit earlier than the energy amplifier one. That is again basically a nuclear reactor, but this time it's designed to eliminate high-level nuclear waste, not to produce energy, just to get rid of the waste.
Okay. Now, my recollection is that the energy amplifier, or the particle accelerator-driven system, produces waste which is, after 300 years, about as radioactive as coal ash.
Yeah, that's right, that's right.
And what that means is, on the one hand, we've got this stuff that some estimates, some people talk about tens of thousands of years, but other estimates that I've seen compare it with the radioactive material that you would find naturally. And it takes about 6 million years to get to that point.
Yeah.
But in either case, you're talking about a period of time that is greatly in excess of that portion of human history that we are aware of. And so, you can fit the rise and fall of the Roman Empire and the building of the pyramids and all of that stuff into that period and say, how long is this going to last? How long can we be certain that there's not going to be a war in Europe? How long can we be certain that there's not going to be a repetition of the Peshtigo fire, which burned down about, an area of Wisconsin bigger than Connecticut? And you can go through these questions. How long is it going to be where we have no Mount Vesuvius eruption? It isn't going to be. But 300 years to get to be the radioactivity of coal ash, I think, is a very acceptable alternative when it's the alternative.
Yeah.
You used a 3-letter acronym, IFR. Is that what
it's the Integrated Fusion Reactor.
Okay. Can you explain what that is in 30 seconds or less?
It was basically, I'm pretty sure it's very similar to the thorium reactor.
Okay.
Where it takes radioactive stuff, and I'm not sure. It was like an old U.S. kind of like sort of secret project, I guess.
Mm-hmm.
And it was shut down very mysteriously.
Okay.
So there's not a whole lot of information. I don't know the process
Mm-hmm.
of how it works, but it sounded, from what I read, like it could take radioactive material and basically process it a bunch of times through the reactor while generating energy until it was very, radioactive for a very short period of time.
Okay. One of the things that I hear with all of this stuff that you're talking about is that you can use the waste to generate, and this could be waste or weapons grade materials, and you could use that to produce power, electrical power.
Mm-hmm.
And the estimates that I have kind of mentally made in my mind say that the efficiency of running nuclear power plants in terms of the amount of the material that's actually turned into electricity is extremely small. It's less than 1%. 98% perhaps of the materials that were originally in that fuel are still there, but we can't use it as fuel. On the other hand, if we could convert it, if you think of the amount of electrical power that those plants have produced over the years, we could get 50 times as much energy as we have out of that. So the fuel at Vermont Yankee, which has kept it going for 40 years, might be useful for over 1,000 years in generating power in a plant of that capacity.
Mm-hmm.
And in other words, this is something that need not cost money. Maybe the cost of this is going to be negative. Maybe there's going to be a lot of money to be made when this comes to fruition. Maybe it's something that could save some of those utilities that we've been talking about that are running into trouble because they've got old nuclear power plants and old coal plants and they don't know what to do.
Right. I agree with you. I think if they move quickly, they could really win big time.
They're basically, with all this nuclear waste, they're almost sitting on fuel reserves.
Yeah, well, they are sitting on fuel reserves. I don't think it's
I was really surprised when I started doing my research. I started looking into it. I thought that the stuff that came out of the nuclear power plants was just radioactive because of the nuclear process.
Mm-hmm.
But I didn't necessarily know that everything in nature is sort of radioactive. And I was very surprised that out of the uranium, we only get like 3% of the potential energy, or less.
And believe it or not, most of that is lost into the atmosphere and rivers and things like that because they can only recover about 35% of it.
Yeah.
So it's just crazy how they are content to continue using this system that is remarkably inefficient.
Yes.
And there's the technology out there for much more efficient systems.
Yes. Yes.
All nuclear reactors being used in this country are based on 50-year-old design.
Well, 50 years?
No, 70 years. You're
70
right.
years.
Probably
I was going to
more.
say, let's go back to the Chicago
you're right.
pile.
I'm losing track of time. You're right.
Yeah, this was before I was born.
Before I was born.
When the first nuclear reaction that produced energy happened, the commuter trains going in and out of Chicago where it happened were driven by steam engines.
Yeah.
They were shoveling coal, and I mean shoveling with a shovel.
Yeah.
They were shoveling coal into those steam engines to get the people to work who were doing that.
Yeah.
So what does that tell you? That was this type of reaction that we've got is archaic. It is, in my opinion, really badly obsolete.
Yep.
We're due for a
new
paradigm.
Maybe. But let's focus on one thing at a time. I think nuclear power, I think personally, still has some attractive features. But not everybody agrees with that, and so therefore let's not worry too much about that. And if it's true that solar and wind can really replace it, why have something that is sort of has dangerous side effects?
Well, are you talking about nuclear power as it's currently being produced?
I think in any, actually, I really shouldn't say what I was going to say. Energy generation is intrinsically dangerous. It's always dangerous.
All energy generation.
Energy, I mean, energy is, I mean, it's, if you've got energy, you've got danger. But the problem with energy generation is you have a very high energy density in one location that then has to be distributed, and the density is lowered.
Right.
And even when it's lowered, I mean, you know, the energy in your electric light, in your electric socket.
Right. I would strongly recommend that you not turn on the light, unscrew the light bulb, and stick your finger.
I would support that.
And the fact is that is that's the distributed energy at its one of its lowest levels, one of its least dangerous levels.
Yes, that's right.
And
I mean, the stuff at the power station is super dangerous. Every power station.
Every power station.
Every power station.
That's right.
A windmill. I mean, I don't know what the operating voltage of a windmill is. What does
it depends upon the design.
But is it thousands of volts, tens of thousands?
I honestly don't know, but I know that there's a lot of variation in them.
But I'm sure it's dangerous because there's energy, and it's all dangerous. But
if it were a tiny wind generator operating at 12 volts, it probably wouldn't kill a person, but you just don't know.
Yeah.
You know, and you don't know what the side effects of a thing like that are, and that's tiny. That would be the kind of thing that a person might put on the top of his cabin of his boat. You know, the wind generators that we have at Searsburg, for example, they're half megawatt, so they're 500,000 watts when they're running at full capacity.
Yeah.
And that's not going to be at 12 volts. That's going to be at a much higher voltage. It might be 400 volts, or it might be even higher than that. I don't know.
Yeah, I don't know. But anyway, it's dangerous. And it's funny that it seems to me that all energy sources kind of have opponents, people who are opposed to them.
Everyone.
But nuclear reactors are the worst, because I think there's a big fear of the unknown, and people are really scared stiff of nuclear power.
The thing that I'm afraid of with nuclear power, when you're talking about safety, is not unknown.
No.
Okay. 480 nuclear power plants have been put online.
Yeah. 12
of them have melted down.
Yeah.
What percentage is 12 of 480?
Ooh, that's a hard one.
We're talking about 2.5% of all nuclear power plants that have ever been put online have melted down. Now, in fairness, I should say, I'm counting as a meltdown, even if just the cladding has melted and you've had some fuel spilled on the reactor floor, that's a meltdown.
Yeah.
It doesn't, and a big meltdown doesn't mean that the vessel is breached and you've got all kinds of things. 3 Mile Island, you had a lot of stuff coming out of that, but you didn't have fuel coming out. And of course at Chernobyl, and probably one of the reactors at Fukushima, certainly one of the reactors at Fukushima threw nuclear fuel 1.5 miles or something did. But Chernobyl, these are big bad ones.
These are big, but there's no doubt we do know how. We have the technology and the know-how to build nuclear reactors that do not suffer from that kind of problem.
Yeah.
On the other hand, you know, there's always a little bit of the unknown when you adopt some new technology. So there might be some new problem with different generation of reactors.
The new technology is being adopted is like buying a new computer with a new operating system.
But anyway,
it's going to be a problem.
Alex and I are certainly not pushing the idea of more nuclear reactors. I mean, not at all. In fact, what we're saying is, look, there is take a snapshot of today. There's a big problem that needs solving. It has to be solved. Somebody has to solve it, and I don't see any sign of our elected officials solving it. I just don't see any sign of it.
Well, I think that crowdfunding the solution to nuclear power is a very interesting option here. It means that a person who wants to get rid of nuclear waste can contribute $5, and if I could afford $5, I would contribute it.
So I'll tell you what, I'll lend you $5 so
you've got a deal.
Okay.
Okay.
Then you'll feel good about yourself
I
because you've done something about the problem.
I've done something about the problem, and you know, if you're talking about an average of $10 being contributed, you only need 10,000 people doing it.
Right.
Well, how many people is 10,000 people? What percentage of the world population is 10,000 people?
Remarkably small.
Remarkably small.
One in a million almost, isn't it, these days?
What percentage of the world population that it could afford $10 is that? It's still a remarkably small percentage. I admit.
Well, if we got everybody on the planet to donate $10, I guarantee we would solve the problem.
We would solve the problem. I have no doubt of that. Getting everybody to do that, I think, would be itself a bit of a
logistics,
problem.
Logistics.
But if people contribute to this crowdfunding thing, you know, you still haven't got the crowdfunding site going, have you?
No.
Yeah.
So we can't even tell people go to the site and look and see what's there.
I mean, you just go to www.kickstarter.
I'll tell you what. Let's do this. I will put up on my website.
Okay.
And I can also tell you that I'll put up on probably. It's hard for me to imagine that Nancy Ray Mallory, who's the editor of Green Energy Times, would refuse this. Put up on that website. A place where the people watching this show can connect once I get that information, and
the other thing is, the way it works is, if you're interested, you just commit to a certain amount, but you don't actually pay anything, because if we reach the target and we get $100,000 or more committed, then everybody has to cough up what they said they would cough up.
Right.
But if we don't hit the target, then
everyone's refunded.
Then we go back to square one and start again.
Right.
And nobody pays anything.
But what this does is it gives people a place where they can actually make a statement.
Yeah, it's almost like voting, you know. It's like a referendum.
Yeah.
You're putting a little bit of money where your mouth is, and you're saying to the government, look, sort this problem out, otherwise we're going to sort it out.
Right. Good point. This is democracy in action.
It's democracy in action.
It's people
really
saying, we have to do something about nuclear waste, and by God, we can.
We can, yeah.
We can.
Yeah.
And, you know, I've reviewed some of the technology, the energy amplifier, the accelerator-driven system. I can actually describe, in terms of the physics, how that works.
Yeah.
I can describe, in terms of the mechanics, a lot of how it works. I know a couple of problems with that, but they're the kinds of problems that are relatively easily solved. And, you know, we've talked about the fact that over an extended period, many, many years, iron, steel slowly dissolves in molten lead. Mm-hmm. But, you know, that's the kind of level of technological problem that.
But I guess the Russians solved that years ago, because they have liquid lead reactors. So
well, the fact of the matter is, if you have two reactors and one of them is in use and the other one is standing there waiting to be used, you can run this one until it's time, and then you pump all that lead over to this one, and you take this one apart and replace it, because it's going to be many years.
Yeah.
So this is not a gigantic. This is more a 19th century solution to a 21st century problem.
Yes.
In terms of that part of the mechanics, but the physics, I feel absolutely confident.
Yeah, the physics is overwhelmingly obvious, and I certainly like that kind of solution personally better than digging a hole in the ground or taking advantage of a hole in the ground that already exists and just dumping this stuff and pretending it doesn't exist anymore. I find that to be a terrible solution. But on the other hand, as Alex said, we are going to get some real experts, nuclear engineers, guys who don't have, I mean, I know some who have not ever been involved in the nuclear waste issues, so they don't have any biases, they don't have any vested interests. There's no reason why they would favor one solution over another. And we want them to just unambiguously analyze the situation with our input. Because, you know, we both know quite a lot about this now. And, I mean, I'm not a nuclear engineer, and neither is Alex.
But you are a physicist.
I am a physicist. Has been.
And Alex is a physicist. To be.
Yeah.
So we're talking about the current outgoing generation and the current incoming generation.
Yeah.
And if I could recommend somebody who's about 40 years old be included in the mix.
Who would that be?
Anybody. But I would bet, you know, that you would find it not difficult to have somebody who would say,
that's right,
I'd love to have my name on that paper.
Yeah.
I would love to see that paper published with my name on it.
Yeah.
And if it's,
I agree.
you know,
That's the way I feel, actually.
it's the way I feel. I would love to participate in a thing like this. I don't have money to contribute aside from the $5 you said you'd lend me.
You could probably sell those suspenders for $5. But of course, that would have a terrible side effect.
It would cost more than that to replace them. but you know, here we've got something, and I should point out to everybody, Steve Reucroft is a physicist who has worked at CERN, who knows Carlo Rubbia, who has a lot of experience in exactly the kind of thing that he was talking about, which is the understanding of the physics. This is a problem of particle physics. We don't care what molecule that plutonium is in. It could be just plutonium, or it could be plutonium combined with something else. It doesn't matter, because it's a physical problem of what happens when it gets struck by a neutron.
Yeah, the nucleus. It's not an atomic problem. Right at the center of every atom is the nucleus, and it's the nucleus we're talking about, the nucleus of the atom. And when you talk about radioactivity, you're always talking about the nucleus.
Right.
It's the nucleus of the atom that decays radioactively,
yes,
because it's unstable. And as Alex said a few minutes ago, it went without notice. I thought he'd pick up on it.
I noticed it. I know exactly what you're about to say. Everything is radioactive.
Except for one thing. There's one thing that's not radioactive.
What is
Do you
that?
know what
Empty
he knows,
space.
because I told him. Do you know what it is?
One thing
There's
that's not
one element that's not radioactive. Only one.
one element or
Yeah.
one isotope?
One element. It's an isotope.
It's an isotope of
It is.
hydrogen.
Hydrogen, yeah.
It's H1.
H1.
Yeah.
That's the only stable atom.
Could I
The
make
only
a
stable
suggestion to you?
And by the way, the theorists, the physics theorists, they claim even that is not stable.
Yes, I know. I was going to say
Even that
somebody
disintegrates
sometime is
radioactively.
going to figure out why that's not stable.
But we've looked and we've looked, and we've never seen any evidence of a hydrogen nucleus decaying. Or
But we have seen bismuth decay.
everything decays.
Well, we've seen bismuth decay, and what we're talking about here is a half-life that is so long
Yeah.
that it's almost unimaginable to me that anybody could figure out when that decays.
Yeah.
The idea of saying here is something that has a half-life that's 10 to the 18 years.
Yeah.
How do you figure that out? I don't know.
It's difficult. Well, the half-life, George talks about the half-life. You may not all know what that means. If you take a chunk of a substance and it's radioactive, the half-life is the amount of time it takes for exactly half of it to have decayed radioactively. And that's why he said something about 6 million years to get rid of radioactive stuff, because after one half-life, so for example, plutonium-239, I guess, the normal isotope, has a half-life of about 40,000 years.
Yeah.
So in 40,000 years, half of it's gone, but the other half is still there.
And as a matter of fact,
40,000 years, half of that half has gone. So it takes a long time.
It's a little worse than that, because most decay processes wind up with radioactive daughter.
Yeah.
And so
They all do, because everything's radioactive.
well, yes, but I mean that we can calculate. Here's another thing that is not regarded as stable.
Yeah.
You know, and there are a few things that we can kind of safely regard as stable, like lead-208, but
iron 56 or whatever.
you know, there's a bunch of them.
But the thing is, I mean, the point I was going to say, I mean, Alex is absolutely right, and George is too. Amazingly, you're right too.
Well, I get there once in a while.
I mean, everything's radioactive. You know, you're sitting there drinking a cup of tea, you're radioactive. Your cup of tea is
if you're
radioactive.
eating a banana, you're eating something that's especially radioactive.
Radioactivity is really not something to be scared of. It's everywhere. Everything's radioactive. It's just the nature of our universe, and we've clearly evolved to handle the sort of background level of radiation that we live with, obviously.
Right, but we haven't evolved to handle plutonium.
No, and you know, until recently, plutonium was always referred to as a man-made element, because the only known examples of plutonium atoms were the ones made inside nuclear reactors by
Although it's easily demonstrated that it does exist in nature.
It's been shown to exist now. It's been found.
Yes.
But only very, 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 very
Tiny
very
amounts, tiny amounts that happen to be near or in deposits of uranium.
Yeah, and in extreme geological conditions.
Right.
But even though I say radioactivity is not something to be scared of, there are some elements that are really nasty, and they're radioactive in a nasty way.
Yes.
And they give out a
plutonium is
lot of
one.
energy, and they give
And
out particles
as a matter
that
of
damage
fact,
your cells. And
radon is another.
radon's another one, yeah.
And you find radon in your basement if you live
you sure
in
do. Yeah,
many
whatever you
places
do,
of
don't go
Vermont.
lie on the floor of your basement. Because radon is a very heavy gas, and pretty much every basement's got radon in it. It's in this country
And
anyway.
in some basements,
Comes out of granite. You know,
particularly, yeah, it comes out of granite, but that's not the only stone it comes out of.
yeah, but so you probably can guarantee you've got radon gas in your basement, but it's a very, very heavy gas, so it will sink and it will just be on the floor in a thin layer.
And it has a very short half-life. It's
Yeah.
about 3.5 days.
Yeah, it's a short half-life.
And if you inhale it,
Yeah,
it will, and if it happens to be in your lungs at the moment it decays, it will leave behind radium, as I recall. Is that correct?
I think that's right. Yeah.
And the radium
I think
is an
that's
alpha
right.
emitter.
Yeah,
I think that's correct, but that is
I think radon's a beta emitter, isn't it?
yeah.
But again, it's nasty stuff. Although, and again, we've sort of adapted. I think anyway, we've evolved to handle a certain
a
level.
certain level.
Yeah.
The radiation that we get in bananas, which is from potassium-40, is something that we have to handle that, because there's a small percentage of, it's about as I recall, it's about a 50th of a percent or a 40th of a percent of all potassium atoms are radioactive, but they're not of the really nasty kinds.
Mm-hmm.
And you know, people should understand what we're talking about here is ionizing radiation. And there are many kinds of ionizing radiation, and some of it is very, very nasty, and some of it is not. Everybody is exposed to ionizing radiation every time he walks out into the sunshine, because ultraviolet light includes a lot of wavelengths that are ionizing radiation, and that's why people can get skin cancer from them.
Yeah.
But they're not really nasty unless you're exposed to too much of them.
But when I was teaching intro to science to students, when I was a professor, I'm not anymore, I'm an ex-professor, I used to take a Geiger counter to class and just turn it on. And they go click, 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 you know, click, 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 a lot of clicks. And the students say, what does each click mean? And you say, well, a particle has just passed through this little thing. And
the particle can come from outer space, or it could come from you.
Yeah, well, or from the sun, or from the galaxy, or from anywhere. I mean, there's particles
From the people in the
zapping us.
classroom.
But all the people in the classroom, yeah, they also. I had a student once who had injection of radioactive iodine because he had some problem with his thyroid, and they wanted to check it out. And his thyroid was super radioactive.
Of course.
We used to take him to class, and we'd be showing the Geiger counter, click, 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 and then he'd put it near his throat. And go, click, click, it's really very, very impressive. And the guy, I mean, he's still alive as far as I know. But last time I saw him, he was healthy. And the kids, you know, they say, well, if there's particles going through like 10 a second through this, does that mean there's 10 a second going through me as well? And of course the answer is yes, you're just being bombarded continuously by this stuff.
Right.
It's just a part of our living condition.
However, there's a big, big difference between having an alpha particle from thorium in your lungs,
That's really bad news.
and having is it a beta particle that comes from potassium-40? I think it is.
Oh God, I don't know. I would think so.
Yeah, I think it's a beta
I would think
particle,
so.
which is the beta particle is basically just an electron moving very fast.
What happens is that if you've got a nucleus and it's a bit unstable, and usually that means it's got one neutron embedded in the nucleus, one neutron too many, and the easy way for it to become stable is that neutron spontaneously explodes and becomes a proton and an electron and a bit of energy. And that is what we call beta decay, and it converts the nucleus into a different isotope of a different material, because a neutron is converted into a proton, and it becomes more stable. That's the most common form of radioactivity, beta decay. If you have a really, really super unstable nucleus and it's really unhappy, then it really has to get rid of a bit more than just one electron. So it spits out a whole chunk of its nucleus, in the form of what's known as an alpha particle. And an alpha particle is identical to the nucleus of helium, the helium atom.
See, I know something.
You know this stuff, yeah. But that's for really, really unhappy nuclei.
Yes, and actually they can decay in other ways. You could have a very big chunk come off.
There are some nuclei. I mean, I was amazed when I found out about this, and we used one of them, californium-252. It actually spits out single neutrons in order to achieve stability. So it just sits there spitting out neutrons. Very, very strange thing to do, but it does it. And we used, and that is a man-made product, californium-252. It doesn't exist in
my
nature.
recollection is that there's a couple of these that actually spit out carbon neutrons.
Spit out
carbon neutrons.
What the hell's a carbon neutron?
I mean a carbon
atom.
A carbon nucleus.
Oh, really? The entire C6, that would be, wouldn't it? 6.
I might be wrong about that, but I know that there was one of them that
it's possible.
You know, you have
helium is 2 protons and 2 neutrons, the nucleus, and carbon is 3. Isn't carbon, or is it 12? Is it 6 protons and 6 neutrons? I think it might be 6 and 6. Helium, yeah, it's 6. It's 12. It's 12.
6 and 6.
No, it's
yeah.
12.
And when that comes out, you know, I would imagine that
beryllium is 6.
That would be something that you would prefer not to argue with.
Yeah, I've never heard of that though. I don't know if it happens.
I remember looking at something and saying, "This is a very strange."
Yeah, that is.
But you know, if you were to take a board and list every isotope that is known to man, and of course there are many isotopes. I don't know how many that are not known to man, but if you could put that board up and take a dart and throw it at it, you would almost certainly hit, on the first hit, something that's radioactive.
Everything's radioactive.
Well, I mean something that is not considered stable.
Yeah, that's very nastily radioactive.
And most of them that human beings know about are things that are so radioactive that they'll decay in a minute or less.
Yeah, I know.
And so that's one of the big problems that we got with nuclear waste. When it comes out of the reactor, the stuff that's disappears in with a half-life of a minute or less there's not a lot of it there. But the stuff that disappears in a month or a year or something like that, there's a lot of that in there.
Yeah.
And so
well, that leads to the other interesting nuclear process that is the one that's used in nuclear reactors, and that's called nuclear fission. And if you take a nucleus, and the only naturally occurring one that this happens to is uranium-235, if you insert one neutron into the nucleus of uranium-235, you make a nucleus that's so darn unstable that there's nothing it can do to achieve stability. So what it does is it just blows up into 2 almost equal pieces, and a few neutrons that wander out as well.
There's no way of really predicting what any given atom is going to do, except that it's going to be 2 almost equal pieces.
Yeah, it's almost always almost equal, but not ever quite equal. and these guys are now called fission fragments, and they're things that are much lower in the periodic table. So they're nasty, but they're usually not as nasty as things higher in the periodic table. Plutonium.
Well, no, they're nasty in
californium,
different ways.
yeah, different ways.
Yeah.
But they usually have short half-lives, so they're radioactive for a short period of time.
Which means that you don't want to go near this stuff.
No.
Where if you had started with the unused uranium fuel, you could go near it fairly safely by comparison. You don't want to be anywhere near the spent fuel of a nuclear power plant because it's got so much of this.
Right, and the high-level nuclear waste has got both components. It's got this nasty stuff that's in the region of uranium in the periodic table, and then it's got this nasty stuff halfway down through the periodic table that's the product of nuclei blowing up into 2 almost equal pieces.
This brings us back to Alex,
exactly.
who's going to save the world.
Yeah.
Well, it's on your shoulders, Alex.
It's my generation. We got to handle this.
Yeah, there's a lot of them. That's the advantage. There's millions of them.
And not only that,
and they can all afford $1, can't they? Everybody can afford.
Everybody can afford $1.
I would think.
But you know, for people in my generation and your generation, which is the same generation, we don't have to worry about things that will happen 30 years from now.
That's right.
He does.
That's right.
And that means that his generation is not only more numerous, but it has got a much clearer motive to deal with this.
Yep.
And crowdfunding a paper that is going to come from fresh thinking,
Yeah.
from sources that are not political,
Right.
that are not vested interests.
People who can't even vote. Isn't that cool?
That's very cool. You
That's
can
very
vote
cool.
with your dollar.
You vote with a dollar rather than a vote, and you can change things much
You
more
don't need
effectively than a
As
vote.
a matter of fact, you don't need a credit card.
No.
You don't need a checking account as long as you've got a PayPal account. Because a lot of these crowdfunding places, you can if you've got a bank account that's associated
I don't
with
think
a PayPal.
Kickstarter uses PayPal. I think they have a
Some
deal
of
with
them do.
Amazon. They have an Amazon payment scheme, I think.
Really? Okay.
Yeah. So I don't know how you pay. Do you know how you pay?
I guess you'd have to have like an Amazon account. Or
Have you got to have an Amazon account? Yeah.
I
But that's
think.
free to set up.
Yeah.
And then Amazon bills you, I imagine. But yeah, it's cool what you say, that this is a way of giving people the opportunity to solve a problem that there's no other way for them to solve. I mean, they can't appeal to the politicians because they don't have a vote. So the politicians say, look, I don't even care about this guy that has a vote. So I'm
An
certainly not gonna care
illegal
about you."
alien. An illegal alien could contribute.
Even an illegal alien. What about a legal alien?
Well, legal aliens are allowed to.
That's me. I'm a legal alien, whatever that means.
Well,
Right.
it means that legally you come from the Pleiades or something.
The planet Bork or Mork or something. Bork.
Mark for
I
Mark.
always liked that program, Mork.
Well, poor Robin Williams.
He was a good guy, yeah.
He
I
was.
mean,
He could have contributed if he'd hung around.
I wish we had him on this program. My goodness.
Oh, you wouldn't. We were talking about him last night, and he was a guy who couldn't do Shakespeare because. Did you ever see the Dead Poets Society?
No.
Well, he's talking to students, and he talks about Shakespeare, and he is giving lines from Shakespeare, and he says, "Is this a dagger before me?" And he has to imitate John Wayne as he does it.
Yeah.
It's like he had the comic thing so ingrained in him
Yeah, I know.
that he had to have fun
Yeah.
with just about everything, and Shakespeare was not an exception.
Yeah, well, that's the way you
But,
should be.
you know, I
Everybody
mean-
should be that way.
We have to deal with the waste, or we're sunk.
Yeah. But you're right, you said something 10 seconds ago, no, a little more now, that really resonated when you said that something bad that happens in 30 years' time, we probably don't need to worry about that.
Yeah.
And that's really what my friend who was in his 60s was meaning when he said, I don't care. It's
But
not my
I'll
problem.
tell you what that reminds me of, and it's something that when I was his age, or just 2 years older, or 3 years older, I was in college, and somebody who I knew came to me in the snack bar and said, such and such a teacher, such and such a professor, had said that in 100 years we would have enough waste in North America to cover the entire continent 6 feet deep.
Mm-hmm.
And a student in the class said, "You're saying this with such equanimity. Don't you care?"
Mm-hmm.
And he said, "I'm not going to be here in 100 years."
Yeah.
And that is where we are. Today,
Yeah.
we're 50 years later, and we're getting to a point where I think today there is only one landfill still open in Vermont.
Oh,
Okay, how are we going to deal with this? Well, we've started to run into waste problems in Brattleboro here. Waste, getting rid of waste is a serious problem.
Mm-hmm.
Well, we've got a landfill. We can't use it as a landfill, but we can use it as a place to put up photovoltaic panels.
Yeah.
So we're getting something out of that.
Yeah.
But the waste we're generating has to be taken away. And all of a sudden we're in a position where it becomes really important that we recycle the plastics and the metals just to keep them out of the landfill.
Yeah.
It becomes really important that we take the food waste and the other waste that we can do it with and compost it just to keep it out of the landfill.
yeah, I know. Yeah.
And because the landfill that we're using is in the next state over. And by the next state over, I'm not talking about Massachusetts, I'm talking about New York. It's got to be trucked all the way across Vermont in order to get it to the landfill.
Yeah.
That costs a lot of money.
Yeah.
Now, The same thing is happening with nuclear waste. 50 years ago, when that professor was saying, I don't care, I'm not going to be here 100 years, American politicians who were not going to be there in 100 years promised that they were going to deal with nuclear waste. And guess what, gang? It hasn't happened.
That's because they're not going to be there in 4 years. That's the problem.
But you see, it's even worse than that, because the technology wasn't there in 50 years. They don't know what the technology is. Now, what do we have to do? We have to come up with a technology.
Right.
That's his problem.
That's right.
And that's what he's volunteering to do. That's what he's stepping up to the plate to do. And I'll tell you, I think he knows, as well as I do and you do, that the technology probably already exists. It's just a matter of implementing it.
It probably does, yeah. And by the way, Alex has devoted a huge amount of time this summer for free. I mean, he hasn't been paid. He's just been doing it for free. So he's given huge amounts of his time. He's looked into this problem. He's written a report for me that was really very valuable.
Is that report going to be made available?
The one he wrote?
Yeah.
It will eventually. We have to take that and we have to add the opinions and expertise of the experts.
This is a project that I think it is very easy to justify moving forward on this. It's very hard not to justify it.
Yeah.
And it isn't going to cost anybody anything except the people who like it and feel like they'd like to put a couple of dollars into it.
Right.
So, and a couple of dollars, one thing I should ask.
Even I can afford a couple of dollars.
The crowdfunding thing, well, you're going to have people who are willing to contribute $100 to this.
Probably.
The crowdfunding
let's hope there's
thing.
1,000 of them.
Huh?
Let's hope there's 1,000 of them, or 1 million, if it would be even better.
Yeah.
I mean, you're not limited to the amount that you're asking. That's just a target.
Yeah. One question I've got, because a lot of the crowdfunding places ask this of the people who are going to have things there, is what are you going to give people who contribute $100 or $10? Do you have an answer for that?
We're working on rewards. We've got a basic idea of what we want to do.
Okay.
We're looking at, for like big contributors, we're looking at giving them a free copy of the report that we put together.
Okay.
And then for like small contributions, we're working on exactly what value, but we're looking like a T-shirt with a cool logo on it, or a customized pen, something like that.
Okay, so these are people who would be contributing more than $5, clearly, because you're not going to get a T-shirt for a $5 contribution.
Yeah.
That would attract 1 million people, but it might put you out of business.
yeah, it would, I think.
But
although you could probably get 1 million T-shirts for less than $5 each, actually.
Yeah, and then mail them.
Yeah, and then you have to have them pick them up.
Yes, but I think that you know, I can see how this would move forward and be very, very valuable. You know, I think we're pretty much at the end of our hour. So I'm going to tell people, if they come to my website, geoharvey.wordpress.com, there's going to be something there. Probably there's a list of articles on the left side of the screen, and I'll somehow get this to the top of that list so that when it comes in, people can just look. Or I'll tell you what I'll do. The first couple of paragraphs on the page are in a sticky thing that has a slightly grayed out background, and it talks about nuclear. The current status of the nuclear reactors in Vermont Yankee, and I can put this right under that. So I will have that up on the website, and we can proceed from there. But you're going to have to get this up to a bunch of places.
Yeah, I know it.
Yeah. Okay. Thank you so much.
We spin and we toil, we work all day, sowing and reaping, we store goods away, so we can be dressed well on the day that we die. We dig and drill and waste what we find, break up the earth, leaving little behind, but we will grow lilies in the by and by.
I had one person I bumped into, and he asked me what I was doing, and I told him, and he said, somebody's doing that out in Nebraska. And I said, who? And he said, a guy named George Harvey.
The famous George Harvey.
Yeah.
Gentle rains can fall upon can stay lovely still.